Kurt here from the Salinas Community Science Workshop, and we're going to do the projects on mirrors and light and optics. And the first one, number one, is going to be about two mirrors together. Well, first we'll play with one mirror, and we'll use two together. Eventually we'll make a little mirror book, put it on a protractor, put things inside, and we'll also make a little light to put in there. All right, so first you get your bag. The bags are divided into TK2 and 3 to 6. The TK2s, they're the same, but I have a few more things prepped for the kids, the younger kids. The 3 to 6 ones are the ones I'll use in the video, so you can see all the steps if you have to do all the steps. They're also divided by 10 packs and 1 packs. So if it doesn't say 10 pack, it's just a 1 pack, and you want to get enough for everybody in your class and 1 or 2 more to make sure you've got enough stuff. All right, so here's the stuff, and you can see the mirrors. These are the 2 mirrors, the most important parts. So the first thing we're going to do is we're going to put the palitos on the back of the mirrors. You can do that with a glue gun. If you have a glue gun, just smack it on there like that. Or you could go to your toolbox. Here we got the toolbox. And by the way, the toolboxes are also a little different. The ones with nothing on them are the ones to use for 3 through 6. And the ones for the TK2 has TK2 on them. And they're almost the same, except they have blunt scissors in there, and they have regular glue if you don't want to use the hot glue. But I'll use the 3-6 ones for the videos here. So as I was saying, if you don't want to use the hot glue, you can also just use tape, and it works just fine. You just put some tape right over the palito and make it stay on the mirror. These first few activities you can do without the stick, but it's kind of nice to have a little mirror on a stick, so that's why we do it. Okay, so then you got your 2 mirrors, and now you take off the plastic on the front, and it becomes super clear. Like that. So first you could just let the kids play with the mirror. You get back. So as you look at the mirror, you can look from close to far, see what you can see, look around, and then you will close your right eye. Now look in the mirror, and the person in the mirror, what eye are they closing? You think about yourself coming around on the back of the mirror. Which eye is it? Oh, it's the left eye. So the person in the mirror is a mirror image. Mirror image, there's a term for you. And so you close that one, you close this one. That's pretty interesting. So it's reversed right to left. But now you can point up. You point up like that. Now which way is the guy in the mirror pointing? Oh, that person's pointing up too. And you point down, and they're pointing down. So like touch the top of your head, touch the bottom of your head. That's all the same. So that's not reversed. It's only reversed right to left. It's not reversed up to down. Now why is that? And if you go like this, then it's kind of the same. And then you could go like this and you look up there. Oh, but now it's reversed. It is reversed up to down. My feet are on top. The person in the mirror, their feet are up on the top, and the head is on the bottom. So it is reversed up and down. Oh, this is very strange. We've been looking at mirrors all of our lives, but actually they're kind of complicated. Okay, so now here's something you can do. You can put the mirror up here, right above your eyes, and so all you're seeing is the floor. If you put your mirror right here, all I'm seeing my feet on the floor. And now I'm only looking in the mirror, and I can walk around, and I could try not to run into things, and it's like an entirely different experience walking with my feet on the ceiling. It's like I'm walking on the ceiling. And it's not that easy. Actually, it makes me a little bit dizzy, and I run into things. And then you can also put it down here. Now you're looking just at the ceiling. You looked at the ceiling, and so the ceiling is up like normal, but there's nothing up there to guide me. So I'm also, it's a little bit difficult to walk around. You can't see what's in front of you, so you run into things. But again, it's like another experience. Whereas usually our eyes are pointing straight ahead, if you look in the mirror, it changes the direction of where the light is coming from, where the images are coming from. So spend some time doing that. Have the kids walk all around, have them run into each other. It's great fun. Okay, and then you come back to the desks, and you're gonna take a piece of paper, any piece of paper, and their little notebooks is good, and any kind of a marker or pencil, and you just put a line, just any little line, and then you put the mirror on the line, and all of a sudden you've got a different line. You've got a different line, and if you move down here, it's different still. But if you move it just the right place, it's the same line, but it can change directions, it can change lengths. And you can change the angle of the line. You can make it bend either way you want. And that's with a straight line. So then you could draw a curved line like that, and you can put it down there, and all of a sudden you have all kinds of options. You can make it like a bird, you can make it like a M, you can make it a complete circle, and you can make it twist around the other way if you have it going the other way. So there's all kinds of things you can do. And then you can do different things like that, and then put it down, and again you get all kinds of different shapes and patterns, because everything in the mirror is the mirror image. It's exactly what's out there, but it's reversed. But it's only reversed one way, as we just talked about. So you could spend some time doing that. And then you could draw your name. You put your name, or any word you want. I put my name like that, and then I'm gonna put my mirror right above my name, and now I'm gonna look in the mirror, and I'm gonna trace out my name. And it's not as easy as it might seem. Don't close your eyes. Keep your eyes. If you close your eyes, you could just write your name, but you want to look in the mirror, only in the mirror, and try to keep your marker right on your name. And if it's too easy for them, they're not following the mirror. And so what they should do then is they should start at the end and start at the bottom, and follow every letter backwards. All right, so that's kind of interesting. Okay, now you want to get both mirrors, and you'll hold them both up and just sort of play around with them. If you hold them like this, you see side to side. If you hold them like this, you'll see one up and one down. And your eyes really don't know how to deal with that, and that's actually the project for tomorrow. So don't spend too much time with that. But instead, you can put the mirrors so they face each other. Now you can look over the top of one mirror into the next mirror, and all of a sudden you can see a lot of mirrors. A lot of mirrors going off into infinity. Now that's actually the project for the third day. We're gonna make an infinity viewer. So yeah, you have them look at that. That's kind of interesting. And then you can also tape them together. So if you put them face to face like that, tape them together just like that, and get some tape, and go over the top a couple of times. Then the last time, you could just keep going 2 or 3 or 4 or 5 times, or you could try to put one right across the edge like this. So it's a book. Now you have a little book of mirrors. Okay? And it should sit on the table like this. That, okay? Now you can look at all that stuff you drew on the paper, you can look at it again now with 2 mirrors. And you can change the angle of the mirrors and see what you see. At every step here, you want to give the kids a chance to play, and you want to ask them, what do you see? What do you see? You go around the room, what do you see? What's going on here? And they start telling you what they see, then everyone else can try to see what that person sees. Because, science is all about observation. That's the first step, is observing nature. And this is part of nature. It's called the physical natural world. So they're observing and describing. The second step after observing is to describe it so you can communicate with your peers. So we're being scientists. As we explore this thing, we're being scientists. All right, so we're looking in here and you see all these different things. And then you can pass out some beads. Every kid gets a couple of beads. Then you put the bead on there. And first you can start with the mirrors apart like this. And you see, how many beads do you see? Oh, well, I see 1 bead. There's one bead in the mirror. And then you just turn it like this. It's pretty soon there's more than 1 bead. Okay, you start seeing all kinds of beads. There's more and more and more beads, and you look closer and closer, you see more and more. You get that bead right up in the corner and squeeze it down there. Pretty interesting. So you can start to say, wait a minute, this is not just a book of mirrors, it's a multiplier. I'm multiplying my beads. Okay? Actually, if you have some money, you could put some money in there and your money starts to multiply. Oh, I've only got a penny, but I can still multiply the penny. So I got 2 pennies and 3 pennies and 4 pennies, and pretty soon all kinds of pennies. There's 10 pennies already, 10 cents right there. You can buy a gumball or something. All right. So now it's time to, after you play around with that, and try to get them to think about what's going on. What determines how many pennies or how many beads you can see. And then you could get out the protractor. This is a protractor, and it measures angles. Usually you use rulers that just measure length, but this measures an angle. And that's what these 2 mirrors are making, is an angle. And maybe they've learned a little bit about angles, but even if they haven't, this is a great introduction. So this angle right here is called a flat angle. It's 180 degrees. 180 degrees from one side all the way to the other side. This point in the middle, that's where you put the fold in the mirrors. It goes right at the point. So that's 180 degrees. You can see the protractor starts from 0, and it goes to 90, and it goes back to 180. And it also starts from 0 on this side. There's 2 scales. So it goes from 0 to 90 and to 180. So you can start from whatever side you want. Now I got some lines drawn on there. Those are important angles. So that's 0, 30, 45, 60, and 90. Okay, so now when you put the mirror down, well, you can take the cardboard and you can glue the protractor onto the cardboard, because then you can pick it up and move it around easier. So you take your little glue stick and you put the cardboard down. You glue this puppy on. Like that. And put it like this. So now there's 180 and there's 90. Put it like this, and 60 and 45 and 30. And so you can ask yourself, well, there's another one that's important, is 120. 120, that's twice 60. So you could put the bead in there, and you could ask yourselves, how many beads do I see? How many beads do I see at 180? How many do I see at 120? At 90? 60? 45? 30? You can keep on going. You can figure out sort of the secret of the mirror book. How does it know how to multiply? And how many images? You call these images, right? Because it's not the real thing. There's only one bead, right? Everything else is an image of a bead. So how many images can you get at different angles? That's the question. So you can have a long discussion with them about that. How many beads? You have them arguing with each other. No, at 90 degrees I see 4. No, I only see 3. And that's great. You have a debate among scientists. That happens all the time. All right. So now the final thing to do, and you might not get to it. If this one goes over, because there's a lot of different activities, you can always do the this next part tomorrow. You can put. Oh, actually, I forgot one thing. All right, here's the last thing to do with the book. You take the book like this, and you can look at it from the side like this. You don't need the bead now. You put it at 90 degrees, exactly 90 degrees, and you look at it from the side. And now you tweak it a little bit, and this is very fun actually. If you put it at the right angle, you can have a single eye. You're a cyclops. You're only one eye. And then if you move it to the side of it, you can see your face just like normal. It's just like a normal face, only it's different. Now I've got 2 eyes, 1 nose, everything's normal. But now, when I cover my right eye, that guy in the mirror is covering his right eye too. It's no longer a mirror image. It's the right way around. You put it like this, and he's covering his right eye. It's amazing. And you can even put it up and down like this, and now that guy in the mirror, he's upside down. I'm right side up here, but he's upside down out there. All right. So that's pretty amazing. And you can move it out, you can squeeze it a little bit further, and now I've got 3 eyes. I'm a 3-eyed monster in there. It's amazing. And you can wink one eye, wink the other eye. It's amazing what you can see with this looking straight into the mirror book. Okay? You take it, you put it so you're looking at yourself perfectly. You got 2 eyes, and you could twist it like this and see what you see. When I'm twisting this way, the guy in the mirror is twisting the other way. All the way till, like I said, I go halfway around like this, and he's all the way upside down. Right side up, upside down. It's kind of amazing. If you go all the way around, the guy in the mirror turned around twice. Don't take my word for it. You can see it yourself. Oh yeah, I forgot the rubber band. To help with this one, you can tie the mirror onto the protractor with the liga, with the rubber band. So now that one on 0 is set, and now this one can move back and forth. And the center is right in the center dot, and the one mirror is right on the 0 line, and then this one can move back and forth. You can use that for all those activities. And then when you pick it up, it'll stay where you put it. When you go inside, upside down, right side back up again. And actually that rubber band is making some interesting lines and images on the mirror as well. Okay. All right, so now we're going to make the circuit, and the TK to 2 grades have already got this these clips hooked onto their battery pack, and the wires, the light bulb is already stripped. But the 3rd through 6th, they can do it themselves, and they can learn all about wires. Okay, so you take your wire strippers. It's got a little latch here. You undo those latches. And you can see from the wires that there's a plastic layer on the outside of the wire. And if you want to connect to that wire, you have to take it off. These battery packs, there's a little tiny piece at the end that's disconnected. And that's not enough. You have to strip off more than that. So you can see there's all kinds of different holes in the wire strippers, and you want the smallest one. It says number 20. So you take that and you clamp it down there, and then you pull it off. Okay, and then you do it again. You want plenty off, you want that much off. Okay, and then you do it to the other side. It works better if you cut a little bit at a time. Like that time I broke a little bit, no problem. Just do it again and again till you get a bunch off. Then it helps to kind of twist it around like that so it all stays together. It's called multi-strand wire. It's got a bunch of little strands of the wire all put together. And then you want to get the alligator clips. These are the alligator clips that you're going to use to connect onto. And there's a little hole in there. There's a screw, but we don't have to use a screw. You just go through the hole and then twist the wires together. You can twist the wires, but it's easier to twist the clip. Twist it like that, and there you go, you're connected. And then there's the other one, goes like this. Push it through the hole. I'm making this look easy. It's actually a little bit more complicated, but since I've done this thousands of times, it comes easy. You twist it together, and there you're connected. So that's the electrical connection, but it's better if you make a mechanical connection too. In industry, this is called a strain relief. So you can pull on the wire and it doesn't affect the electrical connection. So I'm going to tape this on there too. This is just so the wire doesn't break. Okay, I'm going to tape this on here and I'm going to tape this one on here. Now they're stronger. You can pull on them a little bit and they don't break. All right, but like I said, the TK to 2 grades have already got this whole setup. Right? And they've also got this wire stripped. This one is a little bit bigger. Maybe you want to go to the 18 hole and you pull on 18 and get these guys stripped off as well. Just a little bit of the wire showing at the end. And then you connect it up and the light comes on. No, actually, it doesn't have any batteries yet. We got to get some batteries. Hold on. Okay, put the batteries in. Every kid needs to know how to put batteries in something. And the light comes on. Here it is. So if your light doesn't come on, it could mean that the little holiday light is burned out. That could be why they gave them to us. Somebody gave us all these little holiday lights. So no problem, just get another one, get another bag, and get another light. So you can see that's the switch now. When you hook it on, it's on. When you unhook it, it goes off. So now, obviously, the thing to do is to shut off all the lights. Ooh, there it is. And now you put the little light into the mirrors, and now instead of the bead, you're using the light. And you can count the lights going in and out like that. You can hang it over the top too if you want to hang it like that and look at it that way. You see all these different lights. All right. Once again, if you don't get all this done on the first day, it's no problem. You can go to, you can let some of this stuff go over to the second day. But it's important to have a good discussion about what everybody's seeing, all the observations they made, and then also the other thing you can do is to have them draw what they see. Anytime they observe something, you can have them draw it in their notebook or on a piece of paper to more clearly explain what they're seeing. Scientists do that all the time. It's not good enough just to explain it or describe it. You have to kind of draw it or make an image of it. All right, that's the first day. You've also got a little laser in your toolbox. Doesn't work. Oh, it's because there's a little piece of film in there to avoid killing the batteries. Get that out of there. Put the batteries back in. Put the little cap down. Put the lid on again. Now it works.
You have a light and a flashing light and a laser. So now your laser, you could do whatever you want. Don't shine it in the kid's eyes, of course, but you can see, you can find the pathway of the light by moving the laser around. Just one mirror, you can see that it goes in and out, and with two, it goes in and out like that. You can use this on all the projects, whatever you want. You can put the laser beam in and see where it goes. If you have some chalk dust, I don't have any chalk dust, but if you do have some chalk dust, you can sprinkle it around there, and then you can actually see where the beam is going a little bit better. All right, these are safe to shine in people's eyes, but of course you don't want to get kids in the habit of doing that. All right, so there's the laser beam.